Nervous system. So there are two major cell types. There's glial cells that act as support for the nerve cells. So an example of a glial cell would be the Schwann cells here. So I'll try and draw them out. They're sort of like these little circles represent the Schwann cells. And what the Schwann cells do is they produce the myelin, which is this gray little box here you see. And how that supports the nerve cell is that it acts like an insulator. So think of like a wire wrapped in like the rubber. It acts like an insulator to help the information the nerve is transmitting go by faster. And the other type of cell is the neuron cell, which you can recognize as like the yellow part in this diagram. That would be the neuron cell. And the neuron cell is the one that transmits electrical impulses or that transmits the different neurotransmitters, which is basically the chemical signals used to communicate between different cells. Well, the key to sending all these electrical impulses or neurotransmitters is something called action potential. So over here we have a section of the nerve, right? And you may notice that outside I have all these plus signs and inside these negative signs. What I'm trying to show here is that it's more positive outside than it is inside. So outside we have a lot of Na plus ions, and inside we have a few K plus ions. And you might be thinking, oh, well, these are both pluses. How can it be negative inside? Well, just to clarify, it's because there's more positive Na plus ions than there is K plus ions inside. So it's more positive outside than it is inside. And the difference between these like charges is about negative 70 millivolts. And at this charge, I guess we can call it the resting potential for the nerve. If I zoom in here on like the surface of the nerve, if I zoom in, it's the surface. There's a bunch of different channels present. So there's the voltage channels, right? This could be a voltage channel, and there's also sodium potassium pumps present. So this could be like the pump here. These channels are key to generating this action potential. So let's have some Na ions out here and a K plus ion in here. What will happen is usually a stimulus will stimulate this nerve and have these channels open up. And what happens then once these voltage channels are open? Na plus ions would flow in while K plus ions would flow out. And this is called depolarization, and I actually have a pretty good graph here to represent it. So here, negative 70 millivolts, you'll see this is the resting potential. And once a stimulus happens that passes this threshold, right? The stimulus has to be strong enough to pass at least negative 55. If it doesn't, then no depolarization, no action potential will happen. But once it passes this threshold, the voltage channels are open, Na comes in, Na plus rushes in, while K plus rushes out. And once we reach about plus 40 charge, so at the peak here, the Na plus channels close, but the K plus channels stay open. So what that happens is K plus ions keep rushing out, and what we call repolarization happens. So as you can see here, the charge within the nerve cell starts to dip again because all the positive K plus is going out. And because the channels or the voltage channels close so slowly, a hyperpolarization event actually happens where all the K plus moves out of the cell and the cell dips below negative 70 millivolts. And during this stage of hyperpolarization, the nerve usually won't be able to be simulated again until it goes back to its resting state. So say this nerve cell has just undergone their action potential and they now need to pass on their neurotransmitters to another nerve cell to help carry on their message. So what will happen here is that they'll release the neurotransmitters into synaptic cleft here, which is the space between these two neurons. And over here, we have another type of channel called the ligand-gated channel. So I'll draw a quick image here. And what these ligand channels basically are is that the neurotransmitters would attach to these ligand channels, which causes them to open up. So now they're open. And once they're open, the Na plus ions around can now rush in, which then starts the action potential within this nerve cell. And that's sort of how signals get passed on from one nerve cell to the other, thanks to these ligand gated channels and the neurotransmitters.